Welcome, ladies and gentlemen. First of all, sorry I can't be there today. I'm currently highly medicated and falling asleep. So I do apologise. Hopefully I can sort of cover everything we need in today's presentation. But we'll see how we go. If you've got any questions, please email me, and I'll try and get back to you over the weekend. I may be in on Friday, but I might not be. We'll see. If you're in the Line 1 class listening to this on Friday morning, then I'm probably not in class. Anyway, so yeah, today's presentation is on control structures. Now this covers decision making, if then else's. It also covers loops, how to get your program to do the same thing multiple times, which makes your coding a lot easier and a lot more flexible. You can do a lot more things when you loop through code. And same with decision making. You can make your program respond to different inputs based on what the user does, or what the value of a certain command is, or a certain variable is at a time. And logic operators is how you compare two values, or there's also relational operators, which are comparing two values, whether it be a variable or a hard value like like 20, or a string like your name or something like that. So it's comparing values. That's all what decision making and loops is all about. It's just comparing values. So yeah, so these are the relational operators, or the main ones that we'll be looking at this semester. There are others you can get, and Java's got a lot of built-in sort of functions that can do similar things, or more complex things. Anyway, but these are the main ones we're going to be looking at. We've got the equal sign. That's pretty much the base standard. It's whether one value is equal to another value, which is what I'm saying there is both sides are equivalent. So both sides of the equal sign is username equal to Ryan, is favorite TV show Firefly, that sort of thing. So it's whether both sides are equivalent. There's greater than, less than, same as in maths. It's is one value greater than another, or less than, and then greater than or equal to, less than or equal to. They're the sort of the main ones. And then there's the not equal to, which is another important one, which can come up, make your code a bit easier when you get into these sorts of situations, where you can either say when it's any value but this particular one. So yeah, and depending on the language, I believe Java can be either or. The two open and close brackets, greater than, less than, and greater than symbols, or the exclamation mark equals. I tend to use the exclamation mark because that, in programming terms, is more of a not. Or it equates to not, so you can just put a not in front of something. So yeah, I tend to use that one, but I'm pretty sure Java can do both. Anyway, so here's some examples of some relational operators. Excuse me. So you got var total, which is a variable equal to 100. So basically, what you've got there is, like I was saying, both sides of it has to equate to true. It has to be equivalent. What that means is all of these relational operators have to equate to either true or false. So var total equals 100. In Java, you have to put equals if it's a comparison. An equal sign by itself is an assignment statement. So if var total equals 100, if you had the line, if you had the line var total equals 100, that would actually store the value 100 inside var total. Whereas if you say var total equals 100, that's a comparison. So it's a subtle but important difference, which will catch many of you, as it does me every so often, when you try and do a loop or a if then else, and you accidentally leave it as equals. It does some funny things, but you'll see that happen. Anyway, so var total equals 100. That'll either come out as true or false. And we'll look at some examples in a minute, but I just wanted to show you how it's sort of written in Java. Number of cars is not equal to 5, so if you wanted to have a test in your code where it's any number apart from 5, the number of cars, I'm not sure why you'd want to have that condition, but let's say you did. You could say if it's anywhere up to 4 or 6 or above, that would come out as true, whereas if it was 5, it would come out as, that would come out as false. If it was anything else, it would be true. So same with, obviously, Wookiee attacks, if it's greater than equal to 500. Because, as you know, Wookiees kill more than 500 people at a time. Anyway, so they're just some examples of the different operators you can have. As I said, there are many more, but they're the ones. All right, decision making. This is basically if then else. So it's literally you can have 2 possible outcomes, true or false. Same with loops, but if then else are a bit easier to sort of conceptualize to start off with. You can have if something is equal to true, then do this. If it's false, do this other thing. So like simple sort of example is like if you're trying to get into a bar or something like that, the sort of if statement would be at the start, or sort of the workflow would be if the person trying to get in is over 18 or over. If that's true, then they can get in. If it's false, they're not allowed in. So that's the sort of how that would work. So if this is true, then do this. If it's false, do something else. Possibly. You don't have to have the false statement in there. We'll look at that in a second. And you can compound them, which means you can say if 18 or over and has a driver's license. So you can do that, and we'll look at that in a second as well, or further on in the presentation. So here's an example of a flowchart of an if statement. I don't have access to Raptor where I am here, so I couldn't do it in a Raptor format, but I've got this one. The quality also is pretty crappy, so I do apologize. Anyway, so the basic flowchart is you're assigning X to be 100, really simple assignment statement with a really bad variable name. X, as you know, shouldn't be used, but anyway, we'll accept that and move on. And then the condition down there, and Raptor has the same diamond shape for a decision, and that's basically saying if X is less than 25, if it is, you go out the left-hand side of the diamond, so that would go down to output true. If it's false, or if it's 25 or above, you go out the right-hand side. And Raptor does that automatically for you, and it formats it for you. So it's really good. But it's important to make a note here where it says X is less than 25. If I type in 24, it'll be true, so it'll output true, and that's fine. If I output 26, it'll output false, because 26 is not less than 25. But if I enter 25, it'll still output false, because 25 is not less than 25. It's equal to, but that's not the condition. The condition is if X is less than 25. So if I enter 25, or if X's value is 25, sorry, it would output false. So that's something you've got to be really careful of when you're dealing with greater than or less than relational operators, to make sure you're using less than or equal to, or greater than equal to. You've got to make sure really carefully which one you use, and that's why in previous weeks when I've talked about testing, you test the value below the value you want to test against, the value above, and the value itself. So in this case 25, you test below 24, you test 26, which is above, and you test the number itself to see if the logic of your code is right. So yeah, that's just a quick example of a sort of if-then else statement in a flowchart. So in code, in Java, we've got the example on the right hand side there. So we've got a standard scanner object, which we've done before, nothing shocking there. Same with the please enter an integer. It's prompting the user to enter a number, and then collecting it from the user. So the first 3 lines of code there, nothing new. But after the comment there, is the number positive or negative? It's saying if number to test is greater than 0, and then basically what's in between the curly brackets there is saying system out println the number is positive. So the condition for the if statement is in between the two standard brackets before number to test and after the 0. They always have to be there. What's in between those two brackets there is the condition, what's referred to as the condition. And then you got the open curly bracket for the block of code. Now you can have multiple lines of code excuse me, in between the curly brackets. That's not a problem. So yeah, so that's the sort of syntax of Java, how you do an if statement. And a lot of languages are pretty similar with if statements. They're pretty standard in terms of syntax. The brackets might be in different spots, or there might not be brackets, but the basics of syntax is right. And everything, as the last point there says, everything between the two brackets has to equate to true for that code block to run. So you could have compounded statements, which are ands, ors, and nots, which we'll talk about later on. But whatever's in between those brackets, two standard brackets, excuse me, has to come out as true for that system out println command to run. If that's false, it just skips straight over it and goes to the close curly bracket and just runs code after that. And we'll look at that in this case here. The first 3 lines are exactly the same. The if statement, if number to test is greater than 0, still exactly the same. System out println, the number is positive. But in this case, what we've done is we've added an alternate option for the code to run if the condition, the number to test greater than 0, if that equates to false. So if the number is not greater than 0. If that's the case, so basically, yeah, if that's the case, if it's false, it'll output system, or it'll run the code system out println number is negative. So it's a catch-all. If that number to test is greater than 0 is false, it'll just run whatever's in else. It won't run any more tests. It won't, unless you program it, it won't run any more code based on that number to test or the condition. It'll just run whatever's in else. And you can put another if statement in there if you need to. We'll talk about that's called a nested if. The code can get kind of messy, but it is possible to do. You can have lots of if statements within each other. And yeah, there is a logic error in this code. I don't know if anyone can spot it quickly. I'll let you work that out for yourself. But it is about the condition. The logic error is basically held within the condition there. So have a look at that and see if you can work it out yourself. But yeah, just be aware that there is one there. All right, so that's that's your basic decision making. There's if then and if then else. There are other ones. The other sort of major one is case switch statements. I'll talk about that another day. I didn't want to make this presentation too complex. I wanted to keep it nice and simple to if then else's, and we'll look at case switch statements. But basically, when you look at the nested ifs, like I was just talking about, you can simplify those into case switch statements, and it can make your code sometimes more simplified. It can sort of make your code a little more complex too, but it can make your code a bit more simple. Anyway, loops. Loops are another important part of programming because, and this is where the power of computers can come in, because you can set multiple commands in a row and get your computer just to loop through them constantly, depending on what you want it to do. So, and you can change data within those loops. It's just standard code, and yeah, like I said, it's more efficient to code because you write the code once and you can run it many times. So if you had a calculator, for instance, you might want it to just continually loop asking for new numbers to add, and then to which operator you want, add, minus, subtract, add, subtract, multiply, divide, or square numbers and things like that. So you can have just continually loop through, and so you don't have to code that multiple times to get it to add as many numbers as you want, as the programmer wants. You can set it, it's up to the user to say keep entering numbers until they hit equals. So, and that makes it a lot more flexible. There are 4 main types we're going to concentrate on 3 at the moment: for loops, while loops, and do while loops. In some languages, it's called the do while is called a repeat loop. Pascal is one off the top of my head. There may be others. There's also a for each loop, which is a simplified version of a for loop. We'll look at that more detail when we look at arrays in the next week probably, because it makes it a lot easier to read data out of an array. You can't do much. Well, at this level, you can't do much more with it. It's mainly used for reading data out, whereas all the other loops, for, while, and do while, you can do a lot more. They're a lot more flexible in terms of what you can do with those loops. Anyway, so for loops. This is quite a structured loop. Excuse me. It's quite a structured loop in terms of it's for when you have it's when you have a set number of times you want the loop to run. Now, it's not entirely true. You can modify it, but anyway, for the moment, let's just accept the fact that if you want a loop to run for a certain number of times, a specific number of times, you use a for loop. And so you can look at in the syntax on the code on the right on line 7. This is the start of the for loop. We've got for open bracket int loop counter equals 0 semicolon loop counter less than 5 semicolon loop counter plus plus close bracket. Now everything between those brackets is basically a shorthand version of putting up the initializer, the condition, and the modifier. Basically, what that means is in the first section of the for loop before the first semicolon, so after the open bracket before the semicolon, int loop counter equals 0, that initializes the loop. That's the loop variable, which is in this case a loop counter. The loop variable is initialized in this section of the for loop header. The next one in between the 2 semicolons, in this case loop counter is less than 5, is the condition. So same as an if statement. It's the condition. The loop will keep running assuming that is true, or when that equates to true. So as long as loop counter stays beneath 5, less than 5, this loop will continue. And the last section, after the semicolon, in this case loop counter plus plus, that's the modifying section where it modifies the loop variable, or the loop control variable. So what that means is this loop starts off with loop counter equal to 0. Every time the loop runs through between the 2 curly brackets, in this case we've only got the one statement in there, but every time it goes through that code, it'll increase loop counter by 1. Now that's what loop counter plus plus is. It just adds 1 to the value stored in there. So whatever loop counter is, it'll just add 1 to it. And that's a standard thing you see in for loops. But anyway, so the first time it goes through, loop counter is equal to 0. It'll run the line, system out print line loop counter equals 0. You can see the output below. And then it gets to the close bracket and says, aha, okay, I need to modify my loop control variable, which in this case, it runs the command loop counter plus plus. And so loop counter now equals 1. And so it now does the test. Is loop counter less than 5? Well, loop counter is 1, so yes, true, it is less than 5. So it runs the command again, loop counter equals plus loop counter, which is, you see in the output, loop counter equals 1. Then it does the same thing again. It adds 1 to loop counter is now 2. Is that less than 5? It does the condition, yes, that's true, so it runs that command again, loop counter equals 2. And it keeps going until you basically reach the point where the condition is false. Loop counter is less than 5 until that's false. So let's have a look at that for a second, because that's an important point where our loop stops. So we've got loop counter equals 4. Let's assume we've outputted system.outPrintln loop counter equals 4. We've run that command, it's outputted that to the console. Now, Java gets to the close bracket on line 9. it goes back to line 7 and it looks at the modifying variable, modifying code, which is loop counter plus plus. So now loop counter was 4, it now adds 1 to becomes 5. Then Java checks the condition, which is loop counter less than 5. Now that's false, because 5 is not less than 5. So what happens is then Java says, okay, well, it's now false, jump out of the loop, go to line 10 in this case. So it goes to the close bracket on line 9, it says, okay, I'm done with the loop, I'm over it, I've done everything I need to do, I'm going to continue running my program. Now in this case it doesn't do anything because there's nothing after that, but it jumps out of that point because the loop counter is modified before the condition is tested, if that makes sense. So that's just an important point to note, especially in this case if you're using less than 5 or greater than 5, or if you're using less than or greater than. If you're using less than or equal to 5 in this case, it would have outputted loop counter equals 5 again, because the condition was true there. So it's a subtle but important point. You have to be really careful. While loops. Now this does exactly the same thing. The syntax, the output is the same. It just does it in a different way. While loops. First of all, you only have the condition in a while loop, and a do while loop. You only have the condition inside the brackets. So you have to initialize any variables outside the brackets. So that's why on line 11 here I've got loop counter equals 0. And then it says while loop counter is less than 5, and that's written basically like English. While loop counter is less than 5, run this code. It's almost pseudocode, or sort of basic English. So while loop counter is less than 5, run this code. And then it does system out print line loop counter equals 0 in the first case. And then I have to run the loop counter plus plus command. It doesn't have that ability inside the standard brackets on line 12 to modify the variable in there. So it's a lot more flexible. Like you could have on line 14 you could add 2 to loop counter. You could subtract values. You could multiply values. You've got a lot more flexibility in terms of the loop control variable, on how to manipulate that in a while loop and a do while loop. For loops are a lot more restricted. You can get around it, but yeah, while loops and do while loops are a lot more flexible. So same thing as well. This last point here, loop counter equals 4. It ends there because loop counter is increased by 1 on line 14, and then it goes, okay, well, I finished the loop on line 15, it's the close bracket, I go back up to my condition on line 12, loop counter is less than 5, loop counter is now 5, and so that's false, so it jumps out of that, and then goes down to line 16, and then finishes the program, because there's nothing else. But it does test it that way, but so you've got to be careful about where you put your code to modify the loop control variable. In this case on line 14, you've got to be careful where you put that. If you swapped lines 13 or 14 around, you'd have different output. It would have a different value. For instance, if 13 and 14 were swapped, it would increase the value of loop counter before it outputted it. So you'd have system out print line loop counter equals 1 as the first output, because that would happen before it, after it increased the value, and it may end in a different spot. You'd have to look at that and try and imagine it yourself, or run it yourself, see what happens. But yeah, it's very important in a while loop and a do while loop. You have to modify the loop control variable. If you don't, you'll have an infinite loop, and in programming that's generally bad. Generally bad. Sometimes you do want an infinite loop, but that's when programs crash. In another way, that's if they get stuck in a loop, that's when they crash, because they just sit there waiting for something to happen that's never going to happen. So if you try and run code and it gets stuck somewhere, look for infinite loops. So do while loops, very similar to a while loop. The logic is exactly the same, except for one thing, which is the test or the condition is after the loop code. So I still have to initialize my variable on line 17, set it to 0. But line 18, instead of a while loop there, it says do. So it's kind of like English. Do this code while this condition is true. So saying do system out print line loop counter equals plus loop counter, and then increase loop counter by 1 while loop counter is less than 5. So it depends, but it's a very sort of subtle difference between the two, but you use them for different reasons. And we're going to look at this now. What's the difference between these two loops? Now, these are the same loops that we had on the previous two slides. They're exactly the same. Now, can you see what the difference is? If you can't, don't worry about it. It's a logic flow. Go through step by step, looking at each loop, and think about what would happen if loop counter was a different value at the start, the initializing where it says int loop counter equals 0. What would happen if they were different values? Like that. If you start off, instead of setting loop counter to be 0, you set it to 6 on both loops. Have a look at the first loop, the do while. It would say int loop counter equals 6, do system out print line loop counter equals 6. And then it will increase loop counter by 1. Loop counter is now 7. And now that condition, while loop counter is less than 5. Now loop counter is 7. So that would equate to false, because 7 is not less than 5. So it would jump out, but it would have already outputted loop counter equals 6. But looking at the second loop, the while loop, loop counter equals 6 to start off with, while loop counter is less than 5, well, that's already false, because 6 is not less than 5. It's greater than 5. So in this case, it would jump, the condition is false, so it would jump out of that loop and go on with the rest of the program. So the big difference between while loops and do while loops is a while loop will run at least once. If you look at the code in the first instance, loop counter equals 6, it will still output loop counter equals 6. So it runs at least once, whereas a while loop doesn't necessarily run once at all. So you have to be very careful about which one you pick and what you want your code to do. Do you want it to prompt the user at least once or not at all, potentially? So you've got to think about that when you're choosing which loop to use. Excuse me. Alright, so loop control variable. This is how you control how many times the loop is run, and that's the variable you test, or variables you test, to see if it's true or false, depending on how complex your condition is. And it can be any data type. So strings, integers, floats, doubles, any of the primitives that we talked about, they all work. And strings as well, as I said. So it can be any data type. The sentinel value is a term to describe the sort of the breaking point of the loop. When at what point does the loop exit? So the sentinel value in the previous examples would be 5. So while loop counter is less than 5, do this, or whatever the loop is supposed to do. The sentinel value in those cases would be 5. So that's something you need to be aware of. That's a term you need to know. Just what the breaking point of that loop is. And iteration is another key word. That's each time the loop runs, it's referred to as an iteration. So each time it outputted the value of loop counter would be an iteration. So each of those previous loops would go through 5 iterations of the loop to output those 5 outputs on the console. Alright, so this is a flowchart that's a bit out of order. I apologise for that. But a flowchart to sort of show a loop in the... this would be a loop. Sorry. Testing a number to see if it's greater than 25 or not. So it's validating what the user's entering. There's prompting the user for a number over 25. The user types it in, and if it's false, if it's not over 25, then it loops around and continually asks the user for a number over 25. So, common loop mistakes. This comes up, all these things, these 4 things come up regularly, and so don't feel bad if it does happen to you. It's a normal thing to get used to. Forgetting to initialize the loop control variable, mainly that's for whiles and do whiles. For loops, it's kind of hard to miss that, but it can happen. Forgetting to modify the loop control variable, again, whiles and do whiles. For loops, you might forget to modify it, or you don't modify it in the right way. Using the wrong relational operator, that's what I was talking about. Less than versus less than or equal to, or greater than equal to, or even equals and equals. So you've got to be careful about the difference you use there, the differences there. Sorry, and including code inside the loop that belongs outside, or vice versa. So you put the brackets. Basically, you put the brackets in the wrong spot. So really be careful about what code you want to be repeated quite often. So nested loops, similar to nested ifs. Excuse me. And you can have loops within loops, and yeah, they're called inner and outer loops. I want to show you that in person because it's kind of hard to visualize. And but yeah, I just wanted to know that they do exist and you can do them. So, and they can get some quite complex code with nested loops. Okay, so here's an example of a nested loop in a flowchart. As I said, it can be kind of complex, and this flowchart doesn't sort of demonstrate it well. I'd rather show it in Java, but anyway. So you have to have 2 loop control variables. You don't have to, but it's a good idea. Well, it's a good way to conceptualize what's happening. 2 loop control variables, in this case, outer counter and inner counter for the different loops. And in the outer loop, I'm increasing outer counter by 1, and there's a syntax error there. It should be outer counter equals outer counter plus 1, not out counter. So just assume that says outer counter. And then, so that's the outer loop, and you can see that as the line going around to the outside and joining back into the flowchart above that line. And then you've got the inner counter increasing by 1 underneath it. And then so it will output value 1 outer counter and value 2 inner counter. And so it'll run inner counter 20 times, that loop 20 times, and then the outer counter loop 30 times. Now what that means is the first time outer counter goes through, outer counter is 1 based on the command there. And then inner counter becomes 1 as well. And so it'll output value 1 is 1 and value 2 is 2. Value 2 is 1, sorry. And then it'll test inner counter is less than 20, which it is because it's 1. And so it'll jump back and increase inner counter by 1. So now inner counter is 2. So the output would be value 1 is 1, value 2 is 2. So what that means is it will run the inner counter loop 20 times for every time the outer counter loop runs once. So it's actually this seemingly sort of simple code will actually run quite a number of times. And so I'll let you convert that into Java and run and test it if you want, just to see how many times and what it does output. And you can see the values change as you go through. But yeah, it's seemingly simple code, but it will output quite a lot. Anyway, that's just sort of a demonstration. But the Java code, I think, to me, makes it a bit clearer. But anyway. Alright, so here's an example of some loops. One loop. And this code, similar to the flowchart we saw a few slides ago, this validates input from a user. Now, using a loop for validating input is a really common thing because you want to keep prompting the user for the correct information until they enter the correct information. So we're setting up 2 variables on lines 9 and 10, an integer called number and a scanner for for the system. So, nothing new or exciting there. The user input, prompting the user for a number between 1 and 100, and collecting that and storing in a number. Now, the sort of the interesting part of this code here is between lines 17 and 21. It's a while loop that's basically going to keep prompting the user until they enter a number between 1 and 100. And this is introducing the OR command in Java. So line 17 says while number is less than 1 or number is greater than 100. So in programming speak, what that means is number less than 1 or number greater than 100 has to be true. One of those has to be true for the entire condition to be considered true. So if you look around, number less than 1 has got brackets around that, and also number greater than 100 has got brackets around that, and then you've got brackets around all of that together. So it's kind of like in maths when you've got order of operation, you look at the inner brackets first. So is number less than 1, you test that, true or false, or number greater than 100, true or false. And if either of those is true, because that's an OR, the entire condition will be true. So yeah, looking on the right hand side, this is the console output and the input. When I did a test run, it said enter a number between 1 and 100. I entered 999, and because that code in there, when I entered 999, number is less than 1. Well, that's false because 999 is not less than 1, so that's false. Number is greater than 100. That is true. So one side of the OR statement is true, therefore the whole condition is true. So you've got while true, basically, system.println, the number is invalid, which you can see on the right hand side, and then enter a number between 1 and 100, and so the user gets a chance to enter another number. So you can sort of see how we've duplicated code a bit between like lines 13 and 14 and lines 19 and 20, but to the user they don't see that at all. They just see it's prompting the user again for the number. So the second time I run through, the while loop comes back, it's waiting for the number to enter on line 20. I enter the number, this time is -80, which in this case number is less than 1. Well, -80 is less than 1, so that's true. Number is greater than 100, that's false. -80 is not greater than 100. But we've got true or false, so with an OR statement, it equates to true. So again, it says, please enter a number between 1 and 100. And so that's great. It comes up saying, prompts the user again. And this time I entered 0, which is less than 0, is less than 1, sorry. So it's the same sort of condition there. True for the first one, false for the second one. So it says number is less than 1 is true, so I'm going to prompt the user yet again for a number. And this time I entered 1. So on line 20 I entered 1. It goes back up to line 17. Is number less than 1? No, 1 is not less than 1, so that's false. Number greater than 100? Well, no, 1 is not greater than 100, so that's false. So we got false or false. So that means the whole condition is false. So while false, it jumps out of that loop and runs the code after line 21, which in this case is line 23, system.println, you entered 1. So that's how you can use loops to validate input from the user, which is really quite nifty and saves you a lot of time and a whole bunch of if statements if you want to try that. But unfortunately that will sort of usually always fail. But anyway, loops can be used for validating input. Sorry. Alright, so here's just more validating data, a sort of simplified flowchart version. Enter a number over 25, it's the same one as before. Is the number greater than 25? No, just keep looping around until they enter the right number. Okay, so some important terms you've got to be aware of. Loop control variable. It's how many times the loop iterates. Sentinel value, we talked about, that's at what value the loop exits. So in the loop examples, it was 5, excuse me. Iteration is how many times or each time the loop runs, and you can say that the loop iterated 5 times. or it's through the next iteration the loop variable is going to be this. Logic operators, ands, ors, and nots, which we will get into a lot more detail later, hopefully. But just be aware that you can compound both if statements and loops. You can compound the condition. And relational operators, greater than, less than or equal to, not equal to, and that sort of thing. So yeah, logic operators. As I said, we'll get into more detail later, but this is just a brief sort of description of them. Ands, ors, and nots. And means both sides have to be true for the whole condition to be true. Ors mean at least one side is true, which we saw in the validation code, and not. What that does is gets the result of a condition or a variable or something, gets the result of that, whether it be true or false, and just does the opposite. So if the condition ends up being true and then you put a not in front of it, the condition now is false. So that can be quite powerful as well. And here's some examples of some logic operators. If color equals yellow or color equals red, so either whether the user types in yellow or red, it'll still be true. And yeah, so both sides, that's also another important point with Java anyway. Both sides of the OR statement have to be complete conditions. So the example on the second line there, color equals yellow or color equals red, that's what you need. You need to have complete conditions. You can't say color equals yellow or red. Java doesn't work like that. It has to have complete conditions on both sides. So here's an example of AND. We got x equals 100, y equals 5. If x equals 100 and y is greater than 5, then it'll output Star Wars, or if that's false, it'll output Star Trek. So what's it going to output? X is 100, y is 5. So we look at both conditions. If x equals 100, x equals 100, so yes, that's true. The first part of the condition is true. And y is greater than 5. Now y is 5 already. So 5 greater than 5, that's false. So if x equals 100 and y is greater than 5, that whole condition will equate to false because not both sides are true. We've got a true and false. So this will actually output Star Trek. And here's a flowchart version of an AND statement. Raptor again might be a little bit different. I can't remember off the top of my head. So just be aware that that's sort of how you write it in that. Here's an OR, excuse me. I'm slowly dying here. Or x equals 100, y equals 5, same variables here. If x equals 100 or y is greater than 5, so the same as before, except it's an OR instead of AND. So in this case, we've got x equals 100, which is true, or y is greater than 5. Now y is not greater than 5, that's false, but we've got true or false. Therefore, the whole condition is true, so this will actually output Firefly. And not. This is where you get a bit more complex here. You've got to look at each individual condition and then work out the whole condition first and then flip it. So let's look at this one. X equals 100, that's true. X is equal to 100 and y is greater than 5, that's false. So we've got true and false, which we know is the output is false because true has to have both sides of the end as true to equate as true. So we've got true and false, which is false, but we've got the not on the front, so that actually turns that into a true. So this would output Doctor Who. So not, like I said earlier, is really powerful, but it can be kind of confusing when you're looking at the code. So just be aware of that. Okay, summary. Decision making, we've got if then else's. Remember, everything's about the condition, both for decision making and loops. And you've got to work out, you've got to find out in code if it's true or false, and that would determine what path the code will go down for the decision making. And in loops, it will determine if it continues with the loop or jumps out of it. And the three main loops we're going to be looking at: for, while, do while. We might get to for each, but these three are the main ones I want to focus on. And the logic operators, less than, greater than equal to, and also there should be relational operators there as well, which is the ands, ors, and nots. Alright, in my absence, I've put up a folder, a file within a folder up on Google Drive, and it's just called Programming Exercises. You'll also find this presentation up there as well, in PDF and PowerPoint as well, as usual. But there's, I think, 7 or 8 exercises in that. I'd like you to run them, or code them in Raptor first and test them, make sure they work, particularly focusing on your sentinel values, so the values at which the loop exits, and making sure you test below that sentinel value, above it, and the actual sentinel value itself. So make sure you test it properly before you start coding in Java. So yeah, work through those, program in Raptor first and Java, and don't forget to focus on formatting your code, which should be easy in Java. In Eclipse, just Command-Shift-F for format. Comment your code as well, and name your variables properly. So I want you to focus on that as well. We're building up all of that in our programs from now on. I want you to get in the habit of doing that now. It just makes things easier in the long run. Anyway, so there's 7 or 8 questions up there. Just start working through them. If you don't finish them in class after watching this, then you just sort of practice in your own time, do it over the weekend. As I said, I'm available for questions via email. I might not get back to you straight away, but I will get back to you. If you do get stuck in class when I'm not there, ask your friends around you for help, or do some research on the web. Have a look up online about how to do certain things. There's heaps of YouTube videos and tutorials on the web about how to do this sort of decision making in loops. There's just so many websites. So if you do get stuck, don't give up. Just either ask for help or look online, or do both, because there might be a website, either a tutorial or a video that explains in a way that just makes sense to you. So yeah, please don't give up. Just keep working on it, keep plugging away, and look for help yourself. Alright, that's it. Thank you very much.